The story began in North Africa during the autumn of 1942. Operation Torch was underway, and American forces were landing with new equipment that had never seen real combat. Among these untested weapons were the M1 Bazookas, rocket-propelled anti-tank guns that represented cutting-edge technology. Yet there was a critical problem that General Dwight Eisenhower discovered with shocking timing. On the very night before the landings commenced, he learned that not a single soldier under his command had received any training on how to use these new weapons. The inexperienced troops carrying the bazookas soon encountered German forces in the field. When the fighting grew intense, some American units abandoned their equipment, leaving intact bazookas in German hands. What happened next would set in motion one of the most remarkable transformations in military history. The German military recognized immediately what they possessed. These captured weapons represented technology that could fundamentally change how they fought on every front. The implications were staggering. Here was a portable launcher that one or two soldiers could operate alone. It could destroy tanks from distances far beyond what hand grenades or magnetic charges could reach. Every German infantry squad could potentially become an anti-tank force without waiting for specialized equipment or vehicles to arrive. The Wehrmacht's technical intelligence understood at once that this was game-changing technology. German military engineers quickly shipped the captured bazookas back to Germany for examination. They arrived at the Kummersdorf Weapons Proving Ground, situated south of Berlin. There, in specialized facilities built for exactly this kind of work, Wehrmacht weapons experts began the first detailed analysis of American rocket launcher technology. What they discovered would completely reshape how German soldiers fought for the remainder of the war. The technical team found both promise and problems. The American M1 fired a 60mm rocket using battery-powered electrical ignition. The warhead, designed with a shaped charge, could punch through roughly 75 to 100 millimeters of armor under good conditions. A single soldier could carry and operate the whole system. It weighed about 7 kilograms. Yet the German engineers immediately spotted serious weaknesses that would require attention. The battery system posed the biggest concern. German experience on the Eastern Front had taught them harsh lessons about cold weather. In the brutal Russian winter, batteries simply failed. The wooden shoulder stock of the American weapon contained compartments holding 4 diesel batteries, 2 active and 2 in reserve. But in freezing temperatures and moisture, these batteries became unreliable. Any German version would need something better, something that didn't depend on batteries to work. The German engineers also recognized another limitation. The 60mm warhead wasn't powerful enough against Soviet T-34 tanks, which featured sloped armor that defeated smaller-shaped charges. The Wehrmacht already had 88mm shaped charge warheads designed for the Raketenwerfer 43, a wheeled anti-tank rocket launcher. Adapting this existing ammunition to a shoulder-fired tube would provide better armor penetration while taking advantage of production systems already in place. In March of 1943, a critical demonstration took place at Kummersdorf. German weapons officials gathered to observe captured American bazookas being fired. They watched experimental German anti-tank weapons tested alongside them, including the Faust-Patrone designs. What they witnessed convinced the Heereswaffenamt, Germany's Army Weapons Bureau, that developing a German version was absolutely essential. The captured weapons had proven the concept worked. German engineering would make it truly dangerous. The development proceeded with remarkable speed. German engineers made key modifications to the design. They replaced the battery ignition with a magneto system activated by a spring-loaded rod. When fired, the rod struck a generator that created electrical current for ignition. This clever solution eliminated the cold weather vulnerability while maintaining reliable ignition every single time. They also increased the tube diameter to 88mm to use the larger warhead ammunition. This gave them nearly 50% more explosive power than the American original. But this improvement created a serious problem. The German rocket motor continued burning for approximately 2 meters after leaving the launch tube, unlike the American version which burned out inside. This meant greater range and velocity. It also meant a massive backblast that posed serious danger to the operator. Early crews discovered the exhaust could cause severe burns and temporary blindness. Soldiers began calling the weapon Ofenrohr, which meant stovepipe, referring to the way hot gas came pouring back. By July 1, 1943, German military documents officially listed the new weapon as the 8.8 cm Raketenwerfer Panzerbuchse. The designation would soon change to Raketenwerfer Panzerbuchse 43, or RPSB-43 for short. Production preparations were already underway at facilities across Germany, though mass manufacturing wouldn't begin until September. 6 primary manufacturers received contracts for production: Ensinger Union in Feddersheim, Hassag in Moselwitz, Gebrüder Scheffler in Berlin, Jechel in Freistadt, Kromprens in Solingen, and Schricker in Fürth. Each received orders for components or complete weapons. Final assembly occurred at multiple locations so that Allied bombing raids couldn't destroy the entire program. By September 8, 1943, a German military report stated that the weapon would reach frontline troops for testing very soon. On September 30th, the official manual for the Raketenwerfer Panzerbuchse had been completed and published. On October 5th, the first delivery arrived at combat units. 1,500 weapons and 5,000 rockets reached frontline soldiers. The speed of this transformation was stunning. From the moment Germans captured American bazookas to the start of mass production had taken less than 11 months. The numbers showed just how seriously Germany committed to the weapon. Initial orders called for 382,000 units. Material shortages and bomb damage eventually reduced this to 289,151 RPSB-54 models by July 1944, when production ceased for this version. Between December 1944 and the war's end, another 20,740 improved RPSB-54/1 models rolled off the production lines. Manufacturing each weapon required just 10 work hours and cost 70 Reichsmarks. Compare this to the 3.7 cm anti-tank gun, which cost 5,130 Reichsmarks and was nearly useless against modern tanks. A single Panzer Schreck cost less than a military rifle, yet could destroy a 40-ton tank. This economic efficiency made mass production possible even as Germany's war economy contracted. The weapons proved affordable at a time when traditional anti-tank guns consumed enormous resources and steel. But the production process carried a terrible human cost. Hassag, the company operating multiple production facilities, was the third largest exploiter of forced labor in Nazi-controlled Europe. By October 1943, over 60,000 workers labored for Hassag. More than half were forced laborers and prisoners of war, torn from their homes and imprisoned. The company operated 16,081 prisoners in labor camps by 1945. At Hassag facilities in Poland, approximately 35,000 deaths occurred across various camps, though incomplete records make exact numbers impossible to determine. Workers endured 12-hour shifts with exposure to toxic chemicals, brutal beatings, starvation rations, and no sanitation facilities. At the Schlebenberger camp, producing munitions including Panzer Schreck components, between 2,000 and 5,000 female prisoners lived in horrific conditions. The average life expectancy for women in that camp was about 2 months. An explosion there on October 12, 1944, killed 96 prisoner laborers. Combat deployment began in autumn 1943, initially in small numbers as production ramped up. By January 1944, 21,141 had been issued to frontline units. Another 39,126 remained in storage due to distribution problems within the Wehrmacht. German infantry on all fronts demanded the new weapon because they recognized its effectiveness against Allied armor. Forces on the Eastern Front received priority. Soviet tank commanders quickly noticed the changing tactical situation. German infantry, who had previously relied on magnetic mines, anti-tank rifles, and bundled grenades, now possessed weapons that could engage tanks at 150 to 200 meters. Every German strongpoint potentially held multiple rocket launcher teams hidden in concealed positions. The weapon proved particularly effective in defense. German tactical doctrine called for Panzer Schreck teams to establish overlapping fields of fire from hidden locations. Teams would dig staggered trenches no more than 115 meters apart. creating a deadly crossfire for attacking armor. The effective range against moving targets was approximately 100 meters, though stationary targets could be engaged from greater distances. Technical performance data from German tests showed impressive capabilities. The RP's-B Ger 4322 rocket achieved penetration of 160 millimeters of armor at a 60-degree impact angle. At the optimal 90-degree angle, it could punch through up to 230 millimeters. The rocket velocity reached 110 meters per second, compared to the American Bazookas' 85 meters per second. The warhead contained 700 grams of explosive, triple the American weapon's charge. In February 1944, a blast shield was added, creating the RPZ-B-54 model that became the standard production variant. This shield protected operators from rocket backblast, but increased weight from 9.25 kilograms to 11 kilograms. Operators still required protective equipment, including gloves and face protection. The backblast danger zone extended 10 to 30 meters behind the weapon. Western Front deployment accelerated before D-Day. German forces in Normandy received thousands of Panzerschrecks positioned to engage Allied landing craft and tanks near the waterline. The weapons proved effective in the Bocage country, where short-range fighting and abundant hiding spots suited Panzerschreck tactics perfectly. American tank crews, recognizing their own invention being turned against them, developed countermeasures including additional armor and infantry screens. The psychological impact often exceeded the physical damage. Tank crews knew that every hedgerow, every building, every pile of rubble might conceal a Panzerschreck team ready to strike. The distinctive launch signature, a bright flash followed by a smoke trail, became a sight that tank commanders dreaded. Crews reported that effectiveness decreased significantly in areas known to have high concentrations of these weapons. International proliferation began even before the war ended. Finland purchased 1,854 launchers and 18,650 rockets for 200,000 Reichsmarks. Finnish forces achieved remarkable success against Soviet armor. Tests confirmed penetration of 100 millimeters of hardened armor at 30 degrees. Hungary received Panzerschrecks for Operation Spring Awakening in March 1945, Germany's last major offensive of the war. Allied intelligence closely monitored this weapon development. A British report from January 1945 noted that German production of nearly 300,000 units in 18 months exceeded total Allied bazooka production by a significant margin. American ordnance experts recognized that Germans had identified and corrected every weakness in the original bazooka design. They had created a superior weapon from captured examples. The Americans themselves adopted German improvements for later bazooka models. The M9 bazooka, introduced in October 1943, incorporated magneto-ignition similar to the Panzerschreck, eliminating the battery problems that plagued earlier versions. The M20 Super Bazooka, developed late in the war, increased caliber to 3.5 inches, following the German example of using larger warheads for better penetration. Monthly production peaked at 15,000 units in early 1944. Each weapon required components from 32 subcontractors, demonstrating the industrial complexity behind mass production. The improved RPZ-B-54/1 model addressed remaining deficiencies. Introduced in December 1944, it featured a shortened tube length of 135 centimeters and improved rocket propellant that reduced backblast. Despite orders for 48,000 units, only 25,744 were delivered before Germany's surrender. Engineers also developed prototypes using impregnated cardboard tubes to save steel, though none reached production. Cost-effectiveness analysis demonstrates why Germany prioritized Panzerschreck production. The smallest traditional anti-tank gun, the 3.7 centimeter Pak 35-36, cost 5,730 Reichsmarks and was ineffective against modern tanks. A single Tiger tank cost 300,000 Reichsmarks. For the price of one Tiger, Germany could produce over 4,000 Panzerschrecks. Ammunition production matched weapon manufacturing. Over 2 million rockets were produced, primarily the RP's-B Ger 4322 model with its distinctive shape and fin stabilization. Each rocket weighed 3.3 kilograms and came packaged in wooden crates of 2. Special winter and summer variants accommodated temperature extremes that affected propellant performance. Transport frames allowed soldiers to carry 5 rockets, though the weight and bulk limited mobility significantly. The weapon's influence extended beyond World War II. Belgian company Mekar, which had produced Panzerschrecks under license, developed the blindicide RL-83 in the 1950s, using similar principles. The Swiss Army adopted derivatives as the 8.3-centimeter rocket-propelled grenade, maintaining upgraded versions in service through 1980. The basic concept of an oversized shaped charge in a shoulder-fired tube influenced anti-tank weapon development worldwide. Post-war analysis by American ordnance experts acknowledged German achievements. Colonel C.T. Richards wrote in 1946 that the Panzerschreck program represented history's most successful reverse engineering project. Germany achieved mass production in under 7 months from initial capture. They had taken a hastily developed American weapon and transformed it into a mature system that exceeded the original in every performance metric. Soviet forces captured thousands of Panzerschrecks during their advance into Germany. Red Army evaluation noted the weapon's superiority to American bazookas received through Lend-Lease. The Soviets had initially rejected American bazookas as insufficiently powerful, receiving only 3,000 units with minimal ammunition. The German version, with its larger warhead and greater penetration, better suited Soviet tactical requirements. The last documented combat use of wartime Panzerschrecks occurred during the 1948 Arab-Israeli War, when Syrian forces employed captured German weapons. The weapons had traveled from German factories through various conflicts, demonstrating the durability of the basic design. Some examples remained in Third World arsenals into the 1960s. Technical documentation survived in remarkable detail. The Wehrmacht's September 30, 1943. Manual provided comprehensive instructions for operation, maintenance, and tactics. American intelligence translated captured manuals in an October 7, 1944 report detailing German firing procedures, aiming techniques, and safety requirements. These documents reveal the thoroughness of German training programs despite wartime pressures. German records indicate numerous operator casualties from backblast injuries, premature detonations, and enemy return fire attracted by the weapon's prominent launch signature. The 10 to 30-meter backblast zone behind the weapon required careful positioning to avoid injuring friendly troops. Urban combat proved particularly hazardous, as backblast could reflect off walls and injure operators. Comparative analysis with contemporary weapons reveals the Panzerschreck's position in anti-tank weapon evolution. The British Piat, using a spring-launched spigot mortar principle, had greater range but less penetration. The American bazooka offered better portability but inferior armor penetration. The German Panzerfaust provided simpler operation and lower cost but was single-use only. The Panzerschreck balanced these factors, offering reusable capability with substantial hitting power. Manufacturing quality varied significantly as the war progressed. Early production weapons from 1943 featured excellent workmanship with precision-machined components. By late 1944, simplified production techniques and inferior materials reduced quality, though functionality remained adequate. Captured examples show progressive degradation in finish and tolerances as Germany's industrial situation deteriorated. The weapon system's complete infrastructure included training facilities, ammunition depots, repair workshops, and distribution networks. Germany established Panzerschreck training schools at multiple locations, graduating thousands of operators monthly. Specialized repair units maintained weapons at division level. The logistical commitment matched that of traditional artillery systems, demonstrating the weapon's perceived value. Environmental limitations affected combat employment. The weapon proved less effective in extreme cold, where propellant burned inconsistently. Desert conditions caused problems with sand contamination. Rain and moisture could cause electrical shorts in the ignition system. Despite these limitations, the basic design proved remarkably robust. Functioning adequately across diverse combat environments from Arctic Finland to Mediterranean Italy. Allied countermeasures evolved throughout the war. Tank crews welded additional armor plates, hung sandbags, and installed wire mesh screens to defeat shaped charges. Infantry adopted aggressive screening tactics, advancing ahead of tanks to suppress Panzerschreck teams. Artillery and mortars targeted suspected firing positions. Despite these measures, the Panzerschreck remained a serious threat through the war's end. German tactical innovation maximized the weapon's effectiveness. Panzerschreck teams learned to target specific vehicle vulnerabilities, including vision blocks, engine compartments, and track assemblies. Multiple teams coordinated attacks to overwhelm tank defenses. Urban combat tactics evolved to exploit the weapon's capabilities while minimizing exposure to return fire. These tactics influenced post-war anti-tank doctrine worldwide. Production quality control data survives from several facilities. Random testing of production weapons showed approximately 95% met specifications in 1943, declining to roughly 80% by late 1944. The primary failures involved ignition systems and tube integrity. Despite quality issues, the sheer production volume ensured adequate supplies reached combat units. The economic impact extended beyond direct production costs. Germany diverted significant industrial capacity to Panzerschreck manufacturing, including steel, electrical components, and chemical production for propellants and explosives. The program consumed resources that might have produced other weapons. However, the cost-effectiveness compared to traditional anti-tank guns justified this allocation from the German perspective. Training programs evolved based on combat experience. Initial training emphasized accuracy and safety. Combat veterans later provided practical instruction on tactics, camouflage, and survival. The Wehrmacht published numerous training pamphlets and tactical guides specifically for Panzerschreck operators. These materials, captured and translated by Allied intelligence, provide insights into German anti-tank doctrine evolution. Supply chain complexity increased as production expanded. The weapon required specialized components from multiple suppliers, including electrical contacts, optical sights, steel tubing, and wooden components. Rocket production demanded separate facilities for warhead manufacture, propellant mixing, and final assembly. Disruption at any point could halt production, making the system vulnerable to strategic bombing. The Panzerschreck program ultimately demonstrates rapid military adaptation under extreme pressure. From initial capture of American bazookas in November 1942 to mass production by September 1943, Germany transformed a foreign concept into indigenous capability. The program succeeded through pragmatic engineering that adapted existing resources rather than developing entirely new technology. Germany's ability to produce nearly 300,000 Panzerschrecks while fighting a multi-front war reveals remarkable industrial resilience. The weapon emerged from systematic reverse engineering that identified and corrected original design weaknesses. German engineers didn't simply copy the bazooka, they created a substantially improved weapon system that exceeded the original in every measurable performance criterion. The historical significance extends beyond technical achievement. The Panzerschreck represents successful technology transfer under combat conditions, rapid industrial mobilization despite resource constraints, and effective military adaptation to enemy innovations. The program proved that captured enemy technology could be quickly transformed into mass-produced weapons that influence battlefield outcomes. Modern military historians study the Panzerschreck as a case study in successful reverse engineering, rapid product development under wartime conditions, and industrial mobilization. The timeline from capture to mass production remains impressive even by modern standards. Few weapons programs have achieved similar speed, from concept to deployment, particularly when starting from captured enemy equipment. The complete story encompasses technical innovation, industrial achievement, and human tragedy. While German engineering deserves recognition for rapid development and successful mass production, the extensive use of slave labor cannot be ignored. Tens of thousands died producing weapons that extended a lost war. The Panzerschreck's history includes both remarkable technical achievement and systematic exploitation of forced laborers. The Panzerschrecke stands as history's most successful reverse engineering program, transforming captured American bazookas into nearly 300,000 improved German weapons in under 1 year. The program demonstrated that military innovation could be borrowed, improved and mass-produced faster than previously imagined. From the first captures during Operation Torch to the final weapons produced in April 1945, the Panzerschreck represented German industrial capability and engineering pragmatism applied to desperate military necessity. It remains a complex legacy of both remarkable achievement and terrible cost.